Hello, dear student. Welcome to GDC and welcome to today's session. So, dear student, as we had started the Target Pharma MCQ 360 series, in which we are just dealing with the important MCQs that are relevant to the All India Pharmacist examination, Drug Inspector examination, any MRB examination, RRB, Telangana, UPSC Drug Inspector, AIIMS examination. So, dear student, here I am Ankit Sani with this new chapter, that is chemical kinetics. So here also we will start with the top 20 questions from the chemical kinetics. Student, previously like in all the examination, either it's your AIIMS, either it's a railway, all the examination, one question or two question, maybe three question were in the previous examination. So this session is very important. Please watch this session completely, as this is specially designed for you because you are very special student for the GDC. Got it? So first question we are having chemical kinetics. First question we are having, chemical kinetics is a branch of um, physical chemistry deals with. So chemical kinetics, this is in your physical chemistry syllabus of your chemistry. So chemical kinetics is a branch of physical chemistry dealings with the heat change in reaction, physical change in the reaction, and rate of reaction and structure of the molecule. So chemical kinetics, it's a branch of physical chemistry that leads with the rate of the reaction. Here in the chemical kinetics, we are discussing about the zero order reaction, first order reaction, second order reaction, pseudo first order reaction, pseudo zero order reaction, and Arrhenius concept is also there. Half-life concept is also there in the chemical kinetics. So first, the chemical kinetics dealing with the rate of the reaction. So it is a branch of physical chemistry that deals with the rate of the reaction. Second question, okay, rate of reaction, that is the basically we can say chemical kinetics, that is dealing with the rate of reaction. So what exactly the rate of reaction? Okay, so here we are having the first option, the rate of decrease in the concentration of any one of the reactant. Okay, the rate of increase in concentration of any one of the product. Okay, the rate of decrease in concentration of any one of the reactant, or rate of increase in concentration of any of the product. Okay, done. Then sum of rate of decrease in concentration of all the reactant, or rate of increase in concentration of all the product. So rate of decrease in the concentration of one product. Suppose product is converted into the reactant is converted into the product. So here in this case, like a this is decreasing. This is decreasing. So rate is a rate of reaction, or we can say concentration of the reactant is decreasing, and concentration of product is increasing. So here this side, the concentration of product is increasing and reactant is decreasing, because the reaction is moving toward the forward side. Got it? If the reaction is in equilibrium, it means the product and reactant are having the same concentration. So actual rate of reaction, like how much rate of decrease in concentration of reactant, and by how much rate the increase in the concentration of the product. That is the actual definition of the rate of reaction. Next we are having the instantaneous rate of a chemical reaction is. So instantaneous rate of chemical reaction is, first we are having the rate of reaction in the beginning, rate of reaction at the end, rate of reaction at a given instant, and the rate of reaction between two specific time interval. So instantaneous rate of chemical reaction is the reaction instantaneous rate of chemical reaction is the rate of reaction at a given instant. Given the instant, suppose our reactant is converted into the product, and it's take around suppose 2 hour the reaction is there na. So I just want to check what is the rate of reaction at 1 hour. So at a specific given instant, the rate of reaction is called instantaneous rate of the chemical reaction. Got it? Moving toward the next question, which of the following statement for the order of reaction is correct? So initially we had started like chemical kinetics, that is a branch of physical chemistry that is dealing with the rate of reaction. So rate of reaction, that is the rate by which the reactant is decreasing and a product is increasing. So that is the rate of reaction. Next, like what is the order of the reaction? by which order is followed by the reaction. So order can be determined only by experimentally. Okay, order is not influenced by the stoichiometric coefficient of a reaction. Order of a reaction is sum of the power to concentration term of the reactant to express the product. Okay, express the rate of the reaction. Order of reaction is always in the whole number. So it is not necessary like order of the reaction. Yes, it's true, like order of reaction always in the order of reaction can be calculated by experimentally only. Order is not influenced by the stoichiometric coefficient of the reaction, like it is not like Na2CO3 or it is and it is not like NaOH. No. And order of reaction is sum of the power of the concentration of the reactant expressing in their rate reaction, rate-like equation. Yes, order of reaction doesn't means it is in whole number. Order of reaction may be zero also. Next, we are having a reaction proceed by first order and 70% of the reaction completed in the 32 minutes and the time required for 50% completion. So a reaction proceed by first order, that is 75% of the reaction, first order reaction is following. Suppose A is converted into the B. So in this reaction, this is first order reaction, 75% of product, we can say 75% of reaction was completed into 32 minutes. So the time required to complete the 50% of the reaction. So it is like that. Suppose it is like that 100% product is reactant is there. So in the it is converted into 50, then 25. So up to that the reaction is 75% completed and it leads 16 minutes and next 16 minutes. So before 16 minutes the reaction is completed by the 50% and next step is like 12.5%, that takes another 16 minutes. Got it? So in a first order reaction the fraction in first order reaction the like fraction remains same. Next, according to the collision theory of reaction rate, the rate of reaction increase with temperature according to the collision theory of reaction rate, the rate of reaction increase with temperature due to greater number of collision, high velocity of the reacting molecules, greater number of molecules having the activation energy, decrease in the activation energy. So collision theory tell us like reaction rate or rate of reaction increase with temperature due to increase in the number of collision increasing due to increase in temperature. So that is the rate of reaction. In a reaction the threshold energy is equal to activation energy plus what? Activation energy plus normal energy of the reactant. So TE, that is the threshold energy, is equal to activation energy plus normal energy of reactant. Got it? So that is the rate of reaction, threshold energy of a reaction. Next, we are having the rate of reaction that does not involve gas and is not depend on the temperature. The rate of reaction that doesn't involve gases and is not depend on temperature or pressure. That doesn't depend on temperature and pressure. Got it? Next, the rate of reaction increase with increase in the temperature just because of their increase in the number of molecules collision. Number of molecule collision, as in the previous question we had discussed, like the collision theory tell us the rate of reaction increase if temperature is increasing due to increase in the molecular collision. Next, we are having for which of the following the unit of rate and rate constant of a reaction are identical? For which of the following the unit of rate and rate constant of a reaction are identical? For which of the following the unit of rate and rate constant of a reaction are identical? Like second order reaction in which the rate and rate constant are equal. Means two reactant molecules we are having, and secondly like same order of reaction they are having. Next we are having radioactive disintegration is an example of our first order reaction. So first order reaction follow the radioactive disintegration. Next we are having, for a zero order reaction the plot of concentration versus time is linear with. For zero order reaction the plot of concentration versus time is linear with negative slope or zero intercept. Is linear with the negative slope or zero intercept. Because concentration here is doesn't depend on the temperature, time. Next, when one of the reactant is present in such great excess that the concentration may be considered constant or nearly, so reaction is said to be. What is the question? Like if reactant is present in such great excess that its concentration may be considered constant or nearly, so the reaction is said to be pseudo order reaction, because here the two molecules one is in greater extent and another is in lower extent. Suppose if any reaction is between A and B is having very less concentration and A is having very excess of concentration, so that is your pseudo order reaction. So when one of the reactant is present in such great excess that its concentration may be considered constant or nearly, so the reaction is said to be of pseudo order. Next, the minimum energy of a molecule should possess in order to enter into a fruitful collision is known as. The minimum energy a molecule should possess in order to enter into a fruitful collision is known as the threshold energy. So threshold energy, that is the minimum energy required for a molecule to possess an order, or we can say to enter into a useful, fruitful, kindness collision, and it is energy that required to convert the reactant into the product, in simple word. Next we are having the Arrhenius equation is. First we are having influence of catalyst on the rate of reaction, influence of solvent on the rate of reaction, influence of temperature on rate of reaction, influence of solvent on the rate of reaction. So Arrhenius theory, that is Arrhenius equation is influence of the temperature on the rate of reaction. Most important question, student. Previously many of the time this question was asked, and they was demanding like the simple statement they are giving, or we can say they are just asking the question, the rate of reaction is influenced by the temperature, which reaction is depicting, that is Arrhenius equation, or Arrhenius equation is telling that is the influence of temperature on the rate of reaction. Next we are having activation energy of a reaction is, that is the minimum amount of energy needed to overcome the potential barrier. Minimum amount of energy needed to overcome the potential barrier, that is the activation energy. Next we are having the activation energy. The activation energy of a reaction can be lowered by using a positive catalyst. Using a positive catalyst, the activation energy of a reaction can be lowered. The activation energy of a reaction can be lowered using a positive catalyst. The activation energy of a reaction can be lowered, that is the by a positive catalyst, so that the more and more reactant can be converted into the product. Activation energy, as I told you previously, that is the minimum amount of energy that is required to convert the reactant into the product. Next, The half-life of first order reaction is that is independent of the initial concentration of the reactant, direct half-life, that T half. Directly proportional to the initial concentration of the reactant, inversely proportional to the initial concentration of reactant, directly proportional to the square of the initial concentration of the reactant. So half-life of first order reaction, that is independent of the initial concentration of reactant. It doesn't mean how much concentration of reactant they are having. They are not depend on the T half is not depend on the concentration. Like T half, the formula of T half of first order reaction is T half is equal to 0.693 by K. So the rate of T half of first order reaction, that is depend on the K, that is reaction constant. Rate of reaction was found to be equal or its rate constant to any concentration of the reactant, the order of a reaction. So what is question? The rate of reaction found to be equal to its rate constant, okay, at any concentration of the reactant. So it is the case of the zero order reaction. So this question pertain about the zero order reaction, that the concentration of the rate constant at any of the concentration is equal. Next and last question, student. I had completed this question in a very concept in a very speedy format, and I hope you had understand. And I will upload the we will provide the video of the explanation of the all the chemical kinetics in the theoretical form also. So according to this law, according to the law of mass action, the rate of chemical reaction is proportional to rate of chemical reaction. According to the law of mass action, the rate of chemical reaction is proportional to the molar concentration of the reactant. According to the law of mass action, theories tell us that the rate of chemical reaction is proportional to the molar concentration of the reactant. Got it? So this is done about the chemical kinetics. Top 20 questions we had discussed, student. So I hope you all had enjoyed this session completely. You can drop your message in the comment box and you can ask your query from any other source also. Like we are on the Instagram also, Telegram also, Facebook channel we are also having. And student, please try to install the GDC classes GDC classes app from the Play Store if you had not till now, and try to watch try to visit on the courses option, where very happy course for all of you, and that contain a very specialized course and specialized content that is designed for only for you. So thank you so much everyone for connecting with me, and have a good day. Be happy, keep learning. All the best.